In the previous video we have discussed how to identify an exact differential equation, and then if it is an exact differential equation, then how to solve an exact differential equation. Those things we have discussed. So in today's lecture we will discuss how to convert a non-exact differential equations into exact differential equations. So here first of all what we have to observe is that suppose whenever you identify any differential equation is in the form m dx plus n dy is equal to 0, and if it is not exact, so then how to convert that one into exact? So by using some integrating factor. So what is an integrating factor? An integrating factor is nothing but a function. So by multiplying the given dE with that integrating factor, that given dE can be reduced into an exact differential equation. So such type of functions are nothing but known as integrating factors. Okay. Now whenever we identify an equation of the form m dx plus n dy is equal to 0 and it is not exact, in the sense if dou m by dou y is not equal to dou n by dou x, then we have to identify an integrating factor, proper integrating factor we have to identify, and then by multiplying the given dE with that integrating factor, so we can convert the given dE as an exact differential equation. So for that there are certain procedures, standard procedures are there. By using those standard procedures we can identify the integrating factor. So in that one we have certain, as I said, certain procedures. So one is just by regrouping the terms, just by regrouping the terms, or otherwise by directly identifying some function, maybe the integrating factor, like that we can directly identify, and by regrouping the terms we can convert a given non-exact dE as exact dE. And another one, we can take the integrating factor maybe of the form 1 by mx plus ny, or otherwise we can take one more as 1 by mx minus ny as the integrating factor, and two more we have. So if 1 by m into dou n by dou x minus dou m by dou y we can calculate, and if it is a function of y, then the integrating factor is e power integral f of y dy. Suppose 1 by n into dou m by dou y minus dou n by dou x is a function of x alone, then the integrating factor is of the form e power integral g of x dx, or similarly one more choice is there. So in any general thing here we can take it as e power x power h into y power k. So these are the different forms of the integrating factor. Let me once again, just by regrouping the terms or by directly identifying any function. So with our experience and the practice we can find out this may be some function, may be an integrating factor. So like that we can identify the integrating factors and we can solve the dE. Another one is the integrating factor is maybe of the form 1 by mx plus ny, or 1 by mx minus ny, or otherwise 1 by n into something if it is a function of y alone. So then the integrating factor will be like this. If 1 by n into something, if you take, if it is a function of x alone, and the integrating factor may be like this, e power integral g of x dx, and another one is x power h into y power k. So these are the choices we have. So 1, 2, 3, 4, 5, 6 choices we have. Now coming to this, how to identify. So 1 by mx plus ny is an integrating factor, or otherwise 1 by mx minus ny is an integrating factor. So how to identify these things? So for that, depending on the type of the given differential equation, just by identifying its nature and all, so we can find out what is the integrating factor, or what will be the integrating factor we can identify. So one by one we will see. So first of all, we will discuss about when we can take 1 by mx plus ny as an integrating factor. How can we identify that? So for that we have certain procedure. Suppose for example, if the given dE mdx plus ndy is equal to 0, is a homogeneous differential equation if mdx plus ndy is a homogeneous differential equation, then we can say that 1 by mx plus ny is an integrating factor. So undoubtedly we can take the integrating factor as 1 by mx plus ny. Of course, if we say take that 1 by mx plus ny is an integrating factor, then provided 1 by mx plus ny is not equal to 0. So if we can identify that given dE is homogeneous dE, then the integrating factor is of the form 1 by mx plus ny. So we will discuss that concept with the help of one example. So here suppose if that given dE is something like this, some x square y dx minus of x cube plus y cube into dy is equal to 0. So now to take 1 by mx plus ny as an integrating factor, we have to check whether first of all it is exact or not and whether it is homogeneous or not. Okay, now here if you observe, the degree of this term is 3, the degree of this term is also 3, the degree of this term is also 3. Okay, so therefore we can say that this is nothing but a homogeneous differential equation because all the terms are of same degree here. Now first of all let us check whether it is exact or not. So if it is not exact, then we will apply this procedure. Now take this given differential equation as some equation 1. Okay, and let if you it is of the form some m dx plus n dy is equal to 0, means here what is m here? M is nothing but here x square y, and what is n here? N is nothing but minus of x cube minus y cube. Now we will calculate the partial derivatives. Now dou m by dou y is equal to, so partial derivative with respect to y means here x square is nothing but a constant and derivative of y alone we have to take. So x square into derivative of y is 1, means we get it as x square. And similarly we find the partial derivative of n with respect to x, that is dou n by dou x, that is equal to here. So derivative of x cube is 3x square, means minus 3x square minus here y cube is nothing but a constant, so therefore derivative of y cube is 0, means here what we get? So minus 3x square we got it. Okay, so therefore if you observe, so dou m by dou y is not equal to dou n by dou x. Okay, so therefore equation 1 is not exact. Or equation 1 is not an exact differential equation, like that also we can write. Means here what we did, first of all we have verified the exactness of equation 1. So this is the first step what we have to do. So we have identified here the given d is in the form of mdx plus ndy is equal to 0. Now we will verify whether it is exact or not. So means we have taken this, the condition dou m by dou we have calculated, dou n by dou x we have calculated, but it was identified that both are not same. So means now we got that the given dE is not an exact differential equation, but it is in the form of mdx plus ndy is equal to 0. Now we have to see that what is the integrating factor we have to take. So for that one, if you identify the given differential equation is homogeneous, as I said, because all the terms are of same degree, so therefore it is a homogeneous differential equation. Therefore we can take the integrating factor as 1 by mx plus ny. Okay, so now just we'll mention that. You can write, but equation 1 is a homogeneous differential equation. So therefore we can take 1 by mx plus ny as an integrating factor. Now first of all we will calculate that mx plus ny. Now you consider mx plus ny. So if it is not equal to 0, then we can take it as an integrating factor. Okay, so if it is not equal to 0, then we can take 1 by mx plus ny as an integrating factor. So now here what is m is nothing but x square y. So x square y into x plus n. What is n here? N is minus x cube minus y cube into y. So if you simplify this, we get x cube y minus x cube y minus y power 4 we get. So plus x cube y minus x cube y cancels out, then we will get minus y power 4. So minus y power 4 is not equal to 0. So therefore we can take the integrating factor as, therefore the integrating factor of equation 1 is 1 by mx plus ny is equal to minus 1 by y power 4. So this is how we can take it. So here undoubtedly, so as per the rule, undoubtedly whenever mdx plus ndy is a homogeneous differential equation, then we can take 1 by mx plus ny as an integrating factor. Okay, now once if you know that this is the integrating factor, now the next step is we have to multiply the given dE with this integrating factor, and then we have to solve that. Okay, that we will see now. Now our integrating factor is minus 1 by y power 4. Okay, now we just multiply, just by multiplying equation 1 with the integrating factor, that is equal to minus 1 by y power 4 on both sides. Okay, we get, so first term is x square y, so means we will get minus x square y divided by y power 4. Next minus of we have, so minus of 1 by y power 4 into x cube plus y cube into dy is equal to 0. This dx here we have. So this implies, if you observe, minus x square by y cube here we will get. So minus minus plus, just you split it into two parts so that it will be easy. So x cube by y power 4 plus, so y cube by y means 1 by y into dy is equal to 0. So clearly this equation 2 is nothing but an exact differential equation. So if we have any doubt, we can easily verify this. Okay, so first of all, for example, we will try to verify this one. Suppose for example this is some m1 and this is some n1. So this is only for additional information to you, so no need to verify here. Okay, now just we will try to verify. So for that verification, we calculate dou m1 by dou y. So here what is m1? m1 is minus x square by y cube. So with respect to y we are partially differentiating, means minus x square is a constant. Now the derivative of y cube. So derivative of 1 by y cube means y power minus 3, means minus 3 into y power minus 3 minus 1. So that is minus 3 by y power 4. But minus 3 means already here we have negative. So negative, then it will become plus, means we will get 3x square by y power 4. And similarly we will calculate dou n1 by dou x also. So if we calculate dou n1 by dou x, so derivative of x cube, because 1 by y power 4 is a constant here, derivative of x cube is 3x square divided by y power 4, because 1 by y power 4 is a constant, plus derivative of 1 by y is 0 because y is a constant. So means we get, so dou n1 by dou x is equal to 3x square by y power 4. So if you observe, so dou n1 by dou y is also same as 3x square by y power 4. So therefore we can conclude that dou m1 by dou y therefore we can conclude that dou m1 by dou y is equal to dou n1 by dou x. So like this we can verify after multiplying with the integrating factor, but especially in this case no need to verify that, because as the given D is a homogeneous differential equation, so therefore we can, by multiplying that D with 1 by mx plus ny, it will automatically convert it to exact. But for our observation here we have multiplied the given, we have verified this whether it is converted into exact or not. So now here we can easily mention, so therefore equation 2 is exact. So then, so we know what is the general solution. So therefore the general solution of equation 1 is of the form, so we know that what is that, integral over treating y as a constant m1 dx plus integral of the terms in n1 which are free from x whole into dy is equal to c, where c is an arbitrary constant. So this implies integral over treating y as a constant. So what is m1 here? We have m1 as minus x square by y cube minus, so m1 is here minus x square by y cube, we write minus x square by y cube into dx plus integral of, in n1 we have to choose the terms which are free from x. So in this first term we have x cube by y power 4, there we have x term, but here only 1 by y we have which is free from x. So now we can take 1 by y into dy is equal to c. Now we will find the integration. So here minus 1 by y cube is a constant, you leave that because here we have to treat y as a constant, and integral of x square is x cube by 3. So this is x cube by 3 plus, so integral of 1 by y is nothing but log y is equal to c, we can write it. Okay, so now we can leave like this, or otherwise if you want to simplify this one more we can simplify also, or otherwise we can leave like this. So let us see how to simplify this. Okay, we can write it as log y is equal to c plus x cube by 3y cube, okay, or otherwise we can write it as y is equal to e power c plus x cube by 3y cube, or otherwise we can simplify it more. That implies y is equal to, so e power c into, so here we have e power c plus x cube plus the 3y cube. Now we can write it, split it into two terms as e power c into e power x cube by 3y cube. But again that e power c can be taken as another arbitrary constant, means we can write it as y is equal to some c1 into e power x cube by 3y cube, where c1 is nothing but e power c. So what is nothing but, finally we can conclude it as, which is the general solution of the given differential equation 1. So like this, so after identifying that new equation as an exact DE, and after that we know how to solve an or how to find the general solution of an exact DE, just we will follow that procedure, and so that we can finally get the answer or otherwise the general solution. So this is how, whenever we will identify a non-exact DE which is homogeneous, then it can be converted into exact by considering the multiple integrating factor as 1 by mx plus ny, and we can solve like this. Thank you.